Let me set the scene. You finish work late one evening. You come home, turn the lights on, and put a pizza in the oven. It's quite a hot evening as well, so you turn a fan on. While your dinner cooks, you sit down and watch the hot new viral video that everyone's talking about. Right now, millions of people are doing the same as you, so those good folk over at the electric grid see a sharp rise in demand, and they increase production at power stations to meet it. You have a great evening with delicious food and excellent entertainment. Now imagine a different scenario. The world you live in is pretty much the same, except fossil fuels were eliminated a long time ago. But there's a problem. The sun went down at 6 PM and there's no wind. The folk at the grid are panicking as they've got no way to increase power production. Meaning, once again, there's no lights to turn on, no pizza, no video, and worst of all, you might still be at work. Okay, so that might all have been a bit extreme, but there is a big problem with renewable energy, and I'm not talking about how much or how little we use. While we might be used to seeing more wind turbines and solar panels in recent years, for the green energy revolution, that's only half the solution. We also need lots of battery storage. In the past, the question of what happens when the sun doesn't shine and the wind doesn't blow was more of a hypothetical problem. But with renewables making up an ever greater percentage of our energy mix, it's now a serious problem that needs solving. In the UK, the national grid is trying to increase its storage capacity to 200 gigawatt hours by 2050 to reach net zero targets. That's a whopping 640% more than it could store in 2021. You may think the first choice for surplus storage is lithium-ion batteries. These are the gold standard for short-term energy storage. It's the same kind you'll find in your laptop or your electric car, and in 2020 the UK opened its largest lithium-ion facility. But here's the catch. Even if lithium-ion batteries were useful for long-term storage, which they're not, and if mining the raw materials wasn't terrible for the environment, which it is, there's just not enough of it in the world to meet demand. So the folks back in the control room might be able to draw a little bit of energy from lithium batteries, but another lever they may want to pull is marked pumped hydro. Here's how it works. When energy is abundant, water is pumped uphill to a reservoir. When more energy is needed in the grid, water is released to a lower reservoir, turning a generator on the way and producing electricity. It's a clean, elegant, tried and tested solution. In fact, it's already the biggest form of stored energy in the US, but it's expensive and takes up a lot of land. Which is why another technology is being looked to as the future of green energy: gravity-fed batteries. The principle is similar to pumped hydro. Instead of water, a weight is lifted up using power from the grid. Then, when power is needed, the weight is lowered, producing power. One way this is being explored is by Scottish startup Gravitricity, who are planning a trial in an abandoned mine in the Czech Republic. But if you don't happen to have a spare mine shaft lying around, then don't you worry, because there's a more high-tech option: Energy Vault.
We started with combining software with innovation in structural engineering to essentially mirror what is most of energy storage today. What we're doing is mirroring that process and utilizing, instead of water, these composite blocks. Through the night, for example, when consumption of energy is very low, so there's excess, potential energy that then can be used to raise those blocks at height. And then when the energy is needed, of course, they're lower. It turns the motors that generate and discharge the electricity.
Just like a mineshaft battery, Energy Vault generates power by driving a turbine with a gravity-fed weight. The main difference between the two, though, is that where a mineshaft uses one single weight, a typical Energy Vault would use thousands, all housed in a structure above ground. Energy Vault says the benefit of this is that it can serve the needs of multiple customers at any one time, with the power input and output controlled by software. And unlike pumped hydro or a mine shaft, these can be constructed pretty much anywhere.
We decoupled energy and power with our design. That means that essentially the customer can define how much power output they want and how much storage duration they want. and we build it out in a modular way, like any buildings. A customer could decide to discharge 25 megawatts over 4 hours, and that would be 100 megawatt hours of storage capacity, versus a single mine shaft in a single way. It's very difficult to get economies of scale. You're essentially limited to where you deploy to where there's 200-meter holes in the ground.
But what makes it attractive is also what's brought Energy Vault some criticism. Unlike pumped hydro or mineshaft batteries, there's a big materials cost to creating these vaults, which some say could outweigh any carbon savings.
For any gravity solution, like pumped hydro, we have to build a structure. We use very little steel in our solution. So for example, we're using a fiber reinforced concrete material for the structure. The composite blocks are about 25 metric tons each, and those are all made locally. So we don't transport them. That reduces, greenhouse gases from the transport sector, which is one of the highest ones. So we make that all on site, utilizing the soil as a default solution, but can also use waste materials.
Energy Vault has come a long way from its initial design. Whether or not it takes off remains to be seen, but what's important is that we have a variety of solutions to support renewable energy. As different technologies come to maturity, they may succeed or they may fail. So placing bets on many different types stops us from being overly reliant on any one solution. Hopefully, a few years from now, you can relax safely in the knowledge that although it's still a dark night, your power could be coming from chemical batteries, water, mines, energy vaults, or all of them at once. You can learn more about how to solve the battery crisis and the other topics on our channel over on the Energizing World's Best Construction podcast, available right now wherever you get your podcasts. And as always, if you liked this video and you want to learn more about where construction is headed, make sure you're subscribed to tomorrow's build.